Good afternoon, and once again, welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoth. And we continue to explain at Excel International IGCSE 9-1 Mathematics A, Book 2, and we are in topic number 2 and page 31. We are talking about Algebra 6. The topic itself is Algebra 6. And I want us to just talk about inverse proportion. And the example that is outlined there is quite understandable to everybody, because we are talking about the temperature of a cup of coffee decreases as time, of course, increases. Of course, it goes without saying, if you pour some tea in a cup, as the time moves, the temperature drops. So one property increases, which is the time, and the other property decreases, of course, proportionally. But of course, we will understand why is this inverse proportion, and that is exactly what we are here to do in this video. And a graph of temperature, T against time, shows an inverse relationship. Inverse relationship is when one increases and the other one decreases. This can be expressed as T is inversely proportional to, this is the temperature, is inversely proportional to time. The word inverse here is very important. It must be understood as such. This T temperature is inversely proportional. Inverse brings about the aspect of reciprocal. So the temperature T is inversely proportional to time. This is what we associate inverse with, reciprocal. And of course, what we have been doing previously, we substitute the symbol of proportionality with equals K, and we talk about temperature T is K over T. Remember, we should have talked about the temperature is equals to K times 1 over T, but of course, K being over 1, K times 1 is 1. It takes us, or it brings us there. That means what? This, where K, of course, we know it's the constant of proportionality. And I want us to go directly to example 4. Example 4 on page 31. And we are told to express these equations as relationships with constant of proportionality. And we are talking about part A. Y is inversely proportional to x squared. Y is inversely proportional to x squared. Y is inversely proportional to x squared. When we bring in the aspect of the constant, we are going to say y is equals to k over x squared. Please remember, the existence of the word inverse in that statement brings about the reciprocation or the reciprocal. Part B, m varies inversely as cube of n. M varies inversely as cube of n. M varies inversely as the cube of n. And that is just like what we need to know. Now, if you bring the constant, it's going to be m is equals to k over n squared. What about part C? S is inversely proportional to the square root of t. S is inversely proportional to the square root of t. And it's simply as that. S is equals to k over the root of t. That's that. And finally, part D, we are told that v squared varies inversely as cube of w. V squared varies inversely as cube of w. V squared varies inversely as cube of w. And of course, when we bring in the k, this one becomes v squared is equals to k over w cubed. And that is just like what we need to know. V squared is inversely proportional to cube of w, and when we bring in k, v squared is equals to k all over w squared, w cubed rather. I want us to, I don't know whether we are able to look at example 5 in this video, but yes, we can. Let's talk about example 5. Example 5. And in example 5, we are told sound intensity in decibels is inversely proportional to the distance of to the distance. Let's talk about the decibel. Sound intensity is inversely proportional to the distance from the source at a music festival. Let's talk about the sound intensity is inversely proportional to the square of the distance from the source. And at a festival, yes, it is the intensity of the sound was 110 decibels, and the distance then was 3 meters. Find the formula relating I and D. It is just like that. We must bring in the K. So intensity is equals to K over distance squared. And let's talk about substitution now. 110 is equals to K over 9 because 3 squared is 9. And the constant of proportionality is 990. So the formula that is joining the two, intensity and the distance, is that the intensity is equals to 990 over distance squared. And that is part A of that question. That is part A of that question. Let's talk about part B. Calculate the sound intensity 2 meters away from the speaker. Calculate, this is part B now, calculate the intensity which is 2 meters from the source. And of course, the formula applies now. Intensity is supposed to be 990 over 2 meters when squared. And it goes without saying, this is 990 all over 4. What is 990? What is 990 divided by 4, which is 247.5. So the intensity is 247.5 decibels. Of course, these are the units of the sound intensity. That is part B. What about part C? Part C of the same question. At what distance away from the speaker is the sound intensity 50 decibels? At what distance? So we have the intensity, we have the constant, but we don't have the distance. But remember, distance is supposed to be squared. So what do we want to make the subject of the formula? Of course, the D. This is over 1. Since these are two equal fractions, then we are allowed to cross multiply, and we're going to have 50d squared is given by 990. We've just cross multiplied. Divide by 50, divide by 50. And of course, we should know that d squared is 990 divided by 50, which is 19.8, which is 19.8. But remember, this 19.8 is d squared. So at the end of the day, we will be able to know if d squared is 19.8, then getting the square root of both sides, we are going to find d is equals to the root of 19.8. So the root of answer is easily 4.449. Of course, it's going to be 4.45 meters to 2 decimal to 2 decimal places, 4.45 meters to 2 decimal places, or to 3 significant figures, either way. But yes, that is it. We have been able to explain inverse proportion. Anytime we mention inverse, please know it comes with reciprocation. And that is it. Moving forward, let us get to my YouTube channel, subscribe and share widely so that we work together. All right?